Hey everyone, in today's video I'm going to cover environment and shell variables. Now to get things started I want to define a few things, and I want to start off by defining what a shell is. So a shell is a program that provides traditional text-only user interface for Linux operating systems, and its primary function is to read commands that are typed into the command line and then execute them. Okay, so this terminal window we have right here is a shell, and if I open up a new terminal window, we'll just open up a new window here, that creates a new shell. So every terminal instance is a shell. If you log in through SSH, that's going to create a shell as well. Now, when a shell starts a session, it creates a special environment that contains variables that define various system properties. And now these are variables that you can access, you can use in your scripts, you can use in your commands. These are also variables that the system uses to perform certain tasks. Okay, and these variables are broken down into two different categories. We've got environmental variables and shell variables. Now the difference between the two is pretty small. They both do the same thing. The only difference is if your shell creates a child process, it will pass down all of its environmental variables down to that child process, but it will not pass down shell variables. So that's the only difference. Now, I want to show you guys how to actually view your environmental variables. To see your environmental variables, just run the command either print env, or you can run the command env, and they both show the same exact output. Now, if you want to see shell variables, it's a little bit trickier. So the command would be set, and when you run this command without any arguments, what it's actually going to do is it's going to list all shell variables. It's unfortunately also going to list all environmental variables as well as local variables and shell functions. So if we run this, I mean, you can see it's a ton of output, and you can see all the shell functions, and then somewhere in there the shell variables exist. Now, there are definitely some useful environmental variables to remember. You know, we've got what our home directory is. We've got our current directory as well. We've got the user of the shell. So these are all standard shell variables. There's a couple of other important ones like path. I want to cover path. It's an important one to cover. So let's go to the bottom and let's look for path. So path. And this is an important variable as well, but instead of covering it in this video, I actually made a separate video going over the path variable, and the link to that video is going to be in the description below. So definitely check that out. Now, we've verified how to look at variables. Let's take a look at how to create a new variable. So if we want to create a new shell variable, we just pass in the name of the variable, and the common syntax is to do all capitalizations for the name of the variable. So we'll call this my_var, and we'll set it equal to this is my first shell variable. If we hit enter, we can now verify that it was actually created by running set. Remember, we have to use set because it's a shell variable, and then we grep for my_var. And there you go, we created a new variable. And to access that variable, all we have to do is put in the $sign and then my_var. So now we can pass this into any command that we want. So if we do the echo command, we've now successfully passed the value of this variable into the command, and it prints it out. Now if we try to do print env pipe grep my_var, you can see it's not there, and that's because printenv only prints environmental variables, and this is a shell variable. Now, I want to demonstrate the fundamental difference between shell and environmental variables. If I create a child shell process, so I'm going to spin off a new bash shell by running the command bash. So this created a child shell. And we're in that shell. It didn't actually provide any feedback letting us know we're in that shell, but just know that we are. So if I try to access that variable that we created, you can see it's not there. And if we do a set pipe grep my_var, it's not there. And that's because shell variables do not get passed down to child processes. So this bash shell is a child shell of the original shell process that opened it. So if we exit out of here, I'm going to show you guys how to turn this shell variable into an environmental variable. And we do that with the export command. So we do export my underscore var. So now it's an environmental variable. We can verify that by doing printenv pipe grep my underscore var. And remember that printenv only shows environmental variables. So if it's in this list, that means it's an environmental variable. And you can see it's set, so it's an environmental variable. If we go to a new child bash process, a new shell, and then we do a printenv pipe grep my underscore var, you can see now that it gets passed down to the child process. And that's because environmental variables always get passed down to the child process, and we can access it in any command that we want using echo and then my underscore var. So we're now passing it into the echo command. All right, so I'm going to, before I exit out, I want to show you guys one thing. So I showed you guys how to create a shell variable, then convert it into an environmental variable. But what if you just want to create an environmental variable from scratch, all in one line without having to create a shell variable and then convert it? You can always type in the command export, then we do new, or whatever variable name you want to give it. I'm going to call this new var2 equals my second variable. And let's just make sure it actually got created. Okay, so it's in there now. So let me exit out of the child shell that I'm in. And now let me see if this variable is configured here in my original parent shell. And you can see it's not. And this is an important thing to understand, is that the parent shell can pass environmental variables down to child processes, but a child shell or process cannot pass variables back up to the parent. And that's why we don't see new var2 in the original parent shell. So we still have the original my underscore var environmental variable that's set. Let's say we want to change it back to a shell variable. Well, we can do that with the export -n and then the name of the variable. So now this went from an environmental variable back to a shell variable, and we can confirm that by typing printenv pipe grep my underscore var. It's not in that list, but if I do a set pipe grep my underscore var, you can see it's there. So that means it's a shell variable now. And now let's say we want to unset that variable completely and basically remove it. Well, we can do that, and it doesn't matter whether it's a shell variable or an environmental variable. To do that, the command is unset, then the variable name. So this will unset any shell and or environmental variables. So now if we do a set pipe grep my underscore var, you can see it's not set, it's empty. Now, let me quickly just create a new variable. We'll just export. We'll just create the same one again, my underscore var equals my first var. And let me make sure it's actually created. So we have this my underscore var. So I'm going to close out this terminal, this shell, and open up a new one. And let's see what happens. Do you guys think that the variable will still be there? Nope, it's gone. So when we create variables in a shell, those variables only exist for the life of that shell, and then they'll get deleted once we close it out. And this can be a problem because if you're a Linux administrator and you create special variables that you use a lot for your day-to-day tasks, you don't want to have to define and configure them every time you open up a new window. That would require too much overhead and a lot of work. So there is a way to automatically load pre-configured variables every time you open up a shell, but before I explain how to do that, I'm going to have to show you guys, or I'm going to have to explain a few things before we get started on explaining that. So the system treats a shell differently based on whatever they were spawned as. And there's two different types of shells, I guess. You have your login and your non-login shells. And what the difference between the two is pretty self-explanatory based on the name, but a login shell is just a shell session that begins by authenticating the user. So if you SSH into your machine and it prompts you for a username and password, that would be a login shell. Now, in this shell right here, if I type in bash and create a new child shell, well, this new child shell didn't prompt me for a username or password, which means that that would be a non-login shell. Then on top of that, we also have interactive and non-interactive shells. So a normal session, that we open up because we SSH into our machine, that's going to be considered a interactive login shell. Now, if we run a script from a command line, that would be a non-interactive shell. And each shell is a combination of either login, non-login, as well as interactive or non-interactive. So it can be any combination of those two, or I guess those four. Now, the reason why I wanted to go over this is because the configuration files for those shells are going to be located in different places based off of whether they're a login or non-login shell. So a login shell will read its configuration details from the /etc/profile file first, and then after that it will look in the user's home directory. So if we go to the home directory, and then it'll check the user's home directory for specific config details. Now what it actually looks for is a combination of three files. So it looks for the first file that it finds between these three. So there's the bash_profile file, then there's the bash_login, and then the -profile, the .profile file. So it looks for any one of these three files, and the first one it finds, it's going to load that as a configuration. Now for a non-login shell, the first file it will read is the /etc/bash.bashrc, and then after that it will then read the user-specific config file. So it'll go into the home directory, and then it'll look for the bashrc file. So it's going to look for this file. So based off of those two shells, based off the two different types of shells, it's going to look at those specific files. Now, normally we want the configuration for login and non-login to match. So the way to do that is to actually set the configurations on the files that the non-login shell looks for, because those will get copied over to the login shell. So that means the two places we can set an environmental variable would be the /etc/bash.bashrc or the user's home directory /bashrc. So I'm going to change the user's home directory .bashrc file to statically define an environmental variable that'll persist across different shells. So if I open that up, sudo vi.bashrc, and put in my password, you want to go to the bottom of the file and make sure it's at the absolute bottom. You don't want to accidentally be inside one of these functions, or then you'll see some odd behavior. And I'll just call this, so we just put in the same command we would do on the command line. So export, then the variable name. So we'll call this my_var10 equals my 10th variable. Save the configs, and let's see if we can access that. I_var10, and you can see it's not there. So does that mean it didn't work? Well, not exactly. What happens is when you open up a new shell, it will then read its configuration files and then load all the environmental variables from those configuration files. But once it's loaded, it doesn't just continually read that file. So for us to get it to read it again, we have to open up a new shell. So let's close this out and let's open up a new one. So now if we do print env pipe my underscore var 10, that variable is now there. So this is going to be available no matter how many times we close or open up new shells. It'll always be available because each time we open up a new shell, it will load that config file that we modified, which is the .bashrc, and it will then load those environmental variables. Now I want to show you what happens when a different user tries to access that variable. So if we change to user 1, let's see if he can access my var 10. All right, so you can see he does not have this variable set. And the reason why is because we actually set it on the user specific config file for the shell. So if this is in our home directory and we change the .bashrc. So this is only going to change settings for this user's shell, okay? So it's not going to impact other users. Now for user 1, if we needed him to be able to access this variable, we could go into his bashrc file and change that and add that in as well. But if you have a variable that needs to be defined system-wide and all users to be able to access, you don't want to have to go into each user and configure it. So instead you want to define it on the configuration file that applies system-wide so everyone can pull that variable. And if you remember, there's a couple of locations we can do that. We have the /etc/profile, we have the /etc/bash.bashrc, or the /etc/environment. So we can set it anywhere, any one of those. I prefer the bash, that's a typo, but so I prefer this file, so I usually just set this file, but you can go ahead and set all the other ones. Just know that depending on what type of shell gets loaded, it may or may not read those specific files. So you got to pick the right one, and you need to have a solid understanding of which files get read based off of which shell type. So I'm going to open that file up, sudo vi/etc bash.bashrc. Go to the bottom of the file, and I'm just going to export. Call this final var. This is my last variable. Now let's see if that was set. So print env pipe grep final_var. You can see it's not set, but remember the shell loads the configuration file when it first opens up. So it's not going to read it again. So we have to open up a new shell. We have to close out the ones we're currently using. So now let's see if that variable was set. So print env pipe grep final_var. And you can see it's set for this user. Let's see if it's set for all other users. There you go. User 1's variable is set as well. So these variables are applied system-wide, so all users can access them. And that concludes this video. That's all I had to go over. In the following video, I'm going to cover the path variable. So definitely check that out. That's another fantastic video. But you definitely want to finish watching this video first before you see that one, because you need to have a solid understanding of how environmental variables work.